We are studying about frames of reference, inertial and non-inertial. Frames of reference, frames of reference, inertial and non-inertial, inertial and non-inertial, and non-inertial. We have discussed the Newton's law of motion and their limitations. An important point about the first two laws is that they do not hold good in each and every frame of reference. For a body at rest in one reference frame may not necessarily appear to be so in another. It may, for instance, appear to be moving in a circle in a frame of reference, rotating with respect to the first. It is only in every very special frames of reference that the two laws of motion hold good, and it is the inertial frame. Inertial frame of reference is also known as a Newtonian or Galilean frame of reference. It was Galileo who first enunciated the law of inertia, which we refer to as Newton's first law. Motions in inertial frames and non-inertial frames of reference are discussed here. Inertial frame. Newton's first law of motion is also known as the law of inertia. Newton's first law of motion. Newton's first law of motion. First law of motion. Newton's first law of motion is also known as the law of inertia. Is also known as the law of inertia. Law of inertia. Newton's first law is also known as the law of inertia. A reference frame, example coordinate system in which Newton's first law of motion hold good, is known as an inertial frame of reference. A reference frame, example coordinate system. Coordinate system in which Newton's first law, Newton's first law of motion hold good, is Newton's first law motion hold good is known as an inertial frame of reference. Is known as an inertial frame of reference. Inertial frame of reference. In an inertial frame, a body continues in its state of rest or of uniform motion in a straight line as long as no external force acts on it. In an inertial frame, a body continues in its state of rest. Continues in its state of rest in its state of rest are of uniform motion in a straight line. Uniform motion in a straight line as long as no external force as long as no external force act on it. In an inertial frame, a body continues in its state of rest or of uniform motion in a straight line. State of rest. In an inertial frame, a body continues in its state of rest or of uniform motion in a straight line as long as no external force act on it. Okay? All the Newton's law of motion hold good in an inertial frame. All frames of reference moving with a constant velocity with respect to an inertial frame are also inertial frame of reference. All frames of reference moving with a constant velocity with respect to an inertial frame are also inertial frames of reference. So inertial frames of reference can be called an unaccelerated frame of reference. Inertial frame of reference can be called an unaccelerated frame of reference. Example. The best approximation to an inertial frame is a frame of reference in the intergalactic space. Intergalactic space. Non-inertial frame. And next is non-inertial frame. The basic law of physics are not changed in inertial frames of the reference, but when a frame of reference is accelerated relative to an inertial frame, the form of basic physical law, such as Newton's second law of motion, becomes completely different. Such frames of reference having an accelerated motion relative to an inertial frame are called non-inertial frame of reference. Since a uniformly rotating frame has centripetal acceleration, it is also a non-inertial frame. A non-inertial frame is either a frame having uniform linear acceleration or a frame which is uniformly rotating. A non-inertial frame is frame is. A non-inertial frame is either a frame is either a frame having uniform linear acceleration having uniform linear acceleration are a frame which is uniformly rotating, uniformly rotating. Earth non-inertial frame. Earth a non-inertial frame. Earth non-inertial frame. Earth is not an inertial frame. It is a non-inertial frame. Earth is non-inertial frame. The Earth is a rotating sphere as it's rotating about. The Earth is a rotating sphere. The Earth 1 minute. The Earth is a rotating sphere. The Earth is a rotating sphere as it is rotating about. It is rotating about. Sphere. It is rotating about its own axis. Its own axis. It has a centripetal acceleration. It has a centripetal acceleration. It has a centripetal. It has a centripetal acceleration. It has a centripetal acceleration due to rotation. Earth is a rotating sphere as it is rotating about its own axis. It has a centripetal acceleration due to rotation. So Earth is non-inertial frame. In addition, Earth also revolves around the Sun in a period of 1 year in an orbit of radius. Earth also revolves around the Sun. Earth also revolves around the Sun. Earth is also revolves around the Sun in a period of 1 year. In a period of 1 year. In an orbit of radius. Earth revolves around the Sun in a period of 1 year in an orbit of radius equal to 1.49 into 10 to the power 8 kilometer. Its orbital velocity. orbital velocity. Its orbital velocity. V equal to 2 pi r by t. V equal to 2 pi r by t. That means 2 pi multiply 1.49 into 10 to the power 8 into 10 to the power 3 into 10 to the power 3 upon 365 multiply 24 multiply 60 multiply 60 because in 1 year time equal to 365 days, and we also change in second, then 365 multiply in per day 24 hours, then we multiply 24 hours, and in 1 hour equal to 60 minutes, then multiply 60 minutes, and 1 minute equal to 60 seconds, then multiply 60 seconds. We can solve this problem in the form of MK system. MK system मतलब meter kilogram second system. Then the value is 6 into 10 to the power minus 3. 6 into 10 to the power minus 3 meter per second. Meter per second square. Meter per second square. Sorry, this value is also 3 into 10 to the power 4 meter per second. And centripetal acceleration of the earth due to revolution and centripetal acceleration of the earth, centripetal acceleration of the earth due to revolution equal to V square upon R. That means 3 into 10 to the power 4 multiply 3 into 10 to the power 4 upon 1.49 into 10 to the power 8 multiply 10 to the power 3 equal to 6 into 10 to the power minus 3 meter per second square. Thus the reference frame attached to the earth is an accelerated frame and it's their non-inertial frame. For our everyday purpose, the values of centripetal acceleration being small is often neglected and the earth is taken to be an inertial frame of reference. The laws of physics are the same. In all inertial frame of reference. Moreover, it is impossible to detect the state of rest or of uniform motion as the experimental results are the same. This is known as Newton's principle of relativity. In next heading, we will study about Newton's principle of relativity.